Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about kickstarting your organizational transformation to become data-centric through data collection and preparation with our special guest, Sarah Kalicin, Lead Data Scientist at Intel. Hey, Sarah, it's good to have you back again.
Hey, Darren, thanks for having me back.
Yeah, today we're going to talk about data collection and preparation. When we talked about our pipeline, or not our pipeline, our transformational process that we do, this is step 2. The first one was organizational foundation, followed by data collection and preparation. In the next episode, we're going to talk about insight development, and then we're going to talk about deployment, how to operationalize this whole thing. So today, data collection and preparation. So what do you have in store for us today, Sarah?
Yeah, thanks, Darren. So today we're going to talk about, starting to think about the data pipeline. So the data pipeline is really kind of the holy grail of analytics, because this is the thing that basically takes that raw data that we have, lots of it, going and identifying what raw data we need, and start thinking about how do we get it through that data pipeline so that it turns into some really great business insights. Okay.
It's almost like the sausage factory, right? A whole bunch of stuff coming in,
factory.
And I get something valuable on the other end.
And you actually have to start thinking about this as like a manufacturing line, because you think about it, it is really taking raw material, these raw bits, and trying to get, move them through, make changes to them, transform it so you can get this insights. And there's, what these data pipelines are all about is how do you do a choreograph that change, from the raw state to insights. And, the first thing you have to do is identify what data you have. And we're going to talk about kind of a structure, how to do that. How do you ingest the data? How do you prepare that data? How do you analyze that data? And then, have a way of acting on it, being able to consume it.
Okay. So five key steps you said then?
There's five.
Determining the business value of the data first, ingest, prepare, analyze, and then act. Is that
right?
Perfect.
And one of the previous videos, we talked about the organization foundation, which is basically about what is the business strategy and what are the business value that you want. So let's talk about like your manufacturing company, or you're in manufacturing. You're going to want to be asking yourself, okay, how many widgets do we manufacture for a particular day? So if you think about this, you have to think about, okay, let's break those down into questions, because all analytics is about is breaking it down into questions that you want to be able to have that lead you to business value. So three things that come to mind that I would think about. All right, what are the customer requests? So how much demand is there for your widgets? Okay, you're going to also start thinking about, okay, what kind of current supply is already out there? Because you don't want to start making more and more and more widgets when your supply is not going to go down. Then the other part too is your yield loss. Unless you have perfect yield and you don't have yield loss, that's going to be a concern, because sometimes you're going to have big yield losses and sometimes you're going to have minimal losses. And you don't want to be at a point in time where you have high yield losses and you don't have any supply, and you're not going to be able to make up the demand from the customers. So those are three simple, we're going to seem very simple questions to ask, but then you have to start thinking about, how do I quantify these? Maybe the customer requests are really easy, but what happens if they all come in on the same day and you don't have manufacturing capabilities, or you don't have an idea of how much supply you have, or you don't know what your yield loss is? So you need to figure out kind of how do you quantify those components, then you have to ask, where do these data come from? All right, so where do you get that information, and how do you, ingest that information? How do you prepare it so that you can basically be able to estimate these components? Next question, some other questions you're going to be asking are around how reliable are these data? Like, are you missing pieces? Are you getting a complete picture of it? Is this something stable over time? So you're going to need to be looking at what maybe other sources of data that could help, give you an idea, especially if you're finding out that, oh, these weren't all the requests we're getting. There's some other indications
Coming from
going
somewhere
on.
else, maybe, right?
Right. How are these changes happening, and why are these changes happening? That might be another source of information that you need to go out. Then the other question too would be, okay, part of being a manufacturing is being able to get raw product. Well, what happens if it takes 3 weeks to get product to you? So then you have to think about, okay, if I get a big request from customers, I don't have the supply, and I don't know what my yield loss is going to be, then you're going to start having to think about, okay, I need to make sure that I can get the right amount of raw material to be on this. And so I'm going to need to be able to predict out my customer requests, my current supply, and my yield loss, so that I can, be able to make sure I have the right amount of material. So you're going to have to go think about, how does this all come together? And there might be even other questions that come together. So this is where the complexity comes in. And if you're in a real organization, this complexity can be really, really, really complex.
So
all these different data sources.
So that pipeline, that helps simplify how all that stuff comes together, and each data thing that you have would go through a similar pipeline: ingest, prepare, analyze, but they may be different for the different types of data. The ingest may be a little bit different, but the key steps are all there. Is that correct?
There is, and there's also, depending on the data, I mean, you're going to want to bring all that, data together too. So as you're ingesting and storing it, you do want to be able to bring this data together so that you can have a picture. For example, yield loss is going to be a really complex thing, especially if you have really complex manufacturing, because you're going to be looking at the types and the causes and the defects and so forth.
So let's talk about real world. You've given us some great examples. Let's go through this. My approach on identifying the data. Let's start right there.
So you're going to be asking, how many widgets, which are basically, maybe some customer data, supply, and yield loss. So this might be, type of algorithms that you could be using are kind of your typical, maybe some basic analytics and business intelligence. And it basically, you come up and saying, hey, for any given day, it's going to be 10,000, and you can start plotting that over the time. You could be starting to look at the yield, and yield could be using a whole bunch of different approaches. Hopefully you have, if it's the manufacturing, you're going to be using statistical process control, being able to see kind of how your key metrics are performing over time, and making sure they're not drifting in some place, so that they're stable. You could also be looking at, why are the yield losses happening on that? Even if everything is perfectly okay, their tolerances could be not dialed in correctly, or there could be other mechanisms that you're not measuring that could be causing issues. Sometimes tools will start fading, and if you don't realize that they're fading because they've always been stable, that could be a cause. So using a lot of supervised learning, unsupervised learning techniques, which are kind of traditional machine learning, can be used here to, one, start segregating problems, looking at clusters of issues based on historical data, being able to use those clusters to be able to predict and really understand kind of the correlations, and then also being able to see if these correlations are actually the causes of it. And there's some specific techniques that could be used to deduce that down.
So,
And
okay,
then,
quick question here then. So what you're telling me is, depending on the type of data and the questions that I am trying to answer, I would use a different analytics technique.
yes.
You're telling me there isn't one data analytics algorithm, or give me your, super neural network that solves all the problems. It's unique to the problem and the data itself, right?
Right. So one of the things that, data has patterns in it. And we want, we use algorithms to be able to pull those patterns out and understand those patterns. So this is where the domain expertise comes in, because they might understand some aspects that are going on with machine, or some physics on that. Being able to understand those patterns will help the data scientists determine what is the most appropriate algorithms
Or approach, or whatever it is. Yeah.
approach on that.
Okay, so this is great, Sarah. I'm glad you brought this up, because I think a lot of people get confused and they make a fundamental mistake here. They send a data scientist and they say, "Here's a bunch of data. Go tell me what's wrong." And what you just said is really important. The domain expert and the data scientist need to sit down together, because the domain expert understands the data, where it's coming from, and the data scientist understands the approach and the algorithms that we could use to gain more insight. Two separate roles, right?
Right. Because
Okay, very cool.
because one of the things about there's a couple of things that I want to point out about like machine learning. Is one, machines aren't actually learning. It's really, the data scientists understanding kind of the patterns and applying the right machine learning algorithm to that to be able to pull out those patterns. That's one. The second part of that too is why that's important is you want to have the most simple model that you possibly can, to have the highest accuracy. The reason why is, especially in the manufacturing part, is if something says, hey, the yields are predicting to go lower, you now have a whole bunch of engineers who are going, okay, we need to go correct that. But if you can't tell them specifically where the problem is coming from, you basically just lost your engineers, because they're not going to go and fight some fires if they don't know where to go look.
Right. In fact, they may create new fires.
Right. And you basically lost the credibility of your analytic system. And that's what, that's a big concern. And I think this is one of the reasons why organizations aren't gaining the ROI, because they haven't really built these models to a point where they're actionable
Gotcha.
or reflective of what the behaviors are actually happening within the systems that they're trying to predict.
All right, so let's tie this all together with, we talked about the data pipeline, we talked about the business process in determining, asking the right questions, all that stuff. Let's tie that all together to see how, it's almost like our first step into how do we operationalize this, which we're going to go in much more detail later on. But let's dive into this a little bit more. How do these things all work together?
Okay. So, it really comes down to the questions or the business questions that you're asking, and the challenges. So, as I said, how many widgets, to manufacture, that could be, you could be using one type of algorithms or to answer that. Yield, you could be using a whole assortment of algorithms on that. Where deep learning comes in is really around image recognition or natural language processing. So, this is where, the beauty about deep learning is you don't have to actually program the features or the variables that on that. The deep learning algorithm does that in itself, and it's really hard to figure out what those features are because it's hidden somewhere in some mathematical formulas within the structure of the neural nets. But it is powerful to say, hey, to take a widget and put it up to a camera and have it try to figure out if there's a defect on that. So that's basically a category of hey, it has a defect or it doesn't have a defect. It might even be smart enough to even say it's this type of defect. So you can do you can categorize the defect. That in itself, identifying the defect helps it removes having a human actually have to go and look and see on that. And, algorithms don't get tired. So, after, 3 hours of like trying to look at things, chances are they're probably going to do a better job than us humans. But it doesn't help the idea that, hey, there's yield loss. We don't understand why that yield loss happens. So you have to go and have that information tied to a few other algorithms to be able to identify, okay, what's correlating? Have we seen this defect before? And what does it correlate back to? And those are going to be other algorithms too that will help understand and point, hopefully, if you have this set up right, to, to some part of the manufacturing system to explain where that defect come from and have an action for how it needs to be corrected. Okay, so how does that happen? So, the CRIS model has been around for a long time, but it's still, really true to form. First, having the business understanding and understanding that, what do you want to be able to gain from using data? The example I've been using here is how many widgets do we manufacture? Then you're going to need to figure out what data do you have, and I just described that. Then you're going to start figuring out, okay, how do I bring that data together? How do I prepare it? How do I link that data together so that essentially I can quantify, the customer requests, the current supply, and any predictions on, potential yield loss. And essentially, you're going to be going through this and improving this over time. You might see, you're getting more customers and the requests are getting bigger or more diverse. You might not be seeing the stability, or you need more stability in your estimates. So you're going to be honing that over time. So you're going to be using problem solving and continuous improvement practices. And and with the problem solving and continuous improvement practices, this is where the culture of the organization plays in. Because this isn't something that you hand off to a bunch of algorithms. This is where it becomes part of the culture.
So what you're telling me, because I see a lot of CIOs make this mistake, they send a data scientist off to go solve that one problem. They do it once, and they go, all right, now you're going to go somewhere else. So there's no continuous improvement on the process. There's no continuous improvement through data feedback loops and things like that. So they miss the real value of even doing the analytics because they found the solution, or they found a solution once with the data. But what you're saying is you need that continuous improvement, always looking at better ways to improve the results coming out, because you may find something different, is what you're saying. You
can look at something different, and you have to think about, it goes back to one of my original slides that I had. You have to look at this as, what are the short circuits that can happen in this process, in this data pipeline? It could be the data source ends, some behaviors in the data can change that can, that represent something else that's happening that was never considered in this. These are a whole bunch of things that as you're going through, either through improving your models, or just the day-to-day instability of the entire process. Your supplier changes something, or you even change a supplier. How does that
affect you? Yeah,
impact it?
gotcha. So I like how you've laid this out. We talked about the business process at the top, continuous improvement, business understanding, data understanding, all the way to deployment, built on top of this typical core workflow of your data pipeline of ingest, prepare, analyze, and act. And then that's built on top of a data-centric infrastructure, which we're seeing a major shift today, because my data is no longer just in my data center. It's now in the cloud. It's now on the edge. It's in the data center. So understanding that data-centric infrastructure, putting that in place as well. So these three things together, I think, make a world of a difference.
It does. And it shows kind of how organizations have to balance the different aspects: the cultural, the data pipeline, how do you move that data through? It's the software that basically you need to have the software to basically provide the choreograph of how the data is to, instruct going through that data pipeline. And then the hardware is there to enable that movement.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.